Hi from Las Vegas. I am getting refreshed. I'm not running around and having fun that's not something I do. I don't gamble. So I'm actually spending time sleeping, and I'm spending time catching up on all the different tasks I have. So I think you're going to get a new teacher back. So I want to begin with, again, highlighting another cadet or student that I've had in the past. I thought, I'm going to go back in the way past, 25 years back with Cherie Payton. I'm coming back to 2018. Kevin Talde graduated here in 2018, and he's doing fantastic. So Kevin was one of my capstone students, and he was ranked number 5 in his graduating class. He received a scholarship. Right now, he's studying at Lincoln Labs and MIT. This picture is at his commissioning ceremony, which he had up at the 49er club up at the top of this gigantic hill, which Colonel Scaletti told me don't walk up that thing, but I did. So you can't see it in this picture, but I'm dying after that walk. He co-authored 2 publications. One is currently under review, and both were about the 3D body scanner at Fort Jackson and what it tells us about injuries and body composition. His father was a civilian who taught here with me in the 90s in a different department. I think it was history. And in the 90s, we first started coming, and because Congress mandated that 25% be civilian by the year 2000. And his dad was one of that, and so was I. In different departments, they do this differently. So his dad actually spent his whole career at West Point, where our model in the math department is if you start here as a junior civilian, you do have to leave. And so I'm the first one to come back and be one of the senior civilians. The senior civilians are here, and they're very few, and they're here after they've been outside for a long time so that we can actually bring something to the table from outside. So that's the model we have in the math department. But I think it's neat because our children are now old enough to come here, and so Kevin's dad and I had that link as well. So you have a handout, and the very first thing on the handout is just to make sure you understand what I'm covering here about SIL 4. So please make sure your laptops are closed, that your cell phones are put away so that you can pay attention and make sure that you understand where your errors were, because that's where we learn the most. So the first thing that I noticed is that we kind of fell apart on the part where we're supposed to use the 2 proportion app. And so if you go dig into the corrections, it looked like the problem happened a little earlier. So this is just like the yawn and the no seed problem that I did, where I think you understood it when I explained it, but doing it yourself was a completely different scenario. And I think one of the things that made it difficult is this table that you had to fill in. So I took Nick and Michael's table. There's an arithmetic error in there somewhere. I'm not quite sure what it is, because if you add this way, you get 47. Yeah, they add this way, they get 57, but it's not 57. The denominator is actually 47. So you really want to check if these 2 proportions, the kill rates by the red medicine and the blue medicine, are the same. And so most of you labeled this as proportion red, proportion blue, and you had difficulty calculating it from this table because it was not set up like our yawn and no yawn table. But the first thing is that if you're going to use that 2 proportion app, it somehow has to be collapsed to 1 statistic, not 2 of them, and you have 2 statistics here. What you need to do is subtract the 2, and looking at whether these 2 proportions are equal is the same thing as looking at whether their difference is 0. And so if I calculate the difference in proportions here, I get 0.067 actually. I should have rounded it up. The other thing that was weird about this table is you're looking at the total kill rate by the red medicine. It's 32 over 47, and the total kill rate here is 27 over 44. That's not immediately apparent by looking at the table. So I'm suspecting that the table also might have confused you. The next is to generate this null distribution for the case where there was, you want to see what all the noise would be like if the effect of these 2 things were just random. And so just like the yawn study, I'm going to need to generate that null distribution. So the first thing on the left side of this app, if you start putting in numbers into this table and changing it, then you can see what that looks like. Well, first of all, I have to kind of convert what this yawn seed and no yawn seed is. So I took exposed to yawn seed as being exposed to medicine red, and exposed to no yawn seed would be exposed to medicine blue. Not the miss rate, the exposed to medicine blue. And so I took yawning as a kill, and I took no yawning as a miss. And so here I put in the numbers, which are not in the same order, because the 32 that was from destroyed would go here, the 27 from destroyed would be here, that would be equivalent to yawning, and no yawning would be the miss rate. And so then it gave me the right numbers. That's where I found the arithmetic error from Nick and Michael's table. But I just used their numbers and I stuck with it. Here, you might think you see something from the data, or you might feel something, but now you can see from the bar chart, they don't look that widely different. This is why it's very important to use the data. In God we trust, all others must bring data. So right now, my inclination is there's probably no difference in effect from looking at this. The next part also, I think, confused you, like what do I put here, or how do I get this red stuff to show up that people are talking about? Well, the first is that you have to activate the simulation by selecting the show shuffle option. If you don't click that, none of this side will appear. The default is 1 here in the number of shuffles, so that might be confusing. Recall that I actually recorded myself doing the shuffling with the yawn and no yawn. So if you wanted to do that shuffle over and over again, lots of times you have to change that default from 1 shuffle to 1,000 shuffles. Then you have to change this part here to the proportion came out. The difference in proportions came out to 0.067. If you think the red medicine is better than the blue, or however you set up your null hypothesis, then you're looking to the right of this difference, and that would be greater than that difference in proportions. And then you want to count this simulation. What it is if I randomly assigned the red and blue kill rate by shuffling, what would that look like? Well, the mean difference would be around 0, and you see that spike up by 0. And then there's a line drawn of my observation that's 0.067, and I want to count how much of that null distribution is above this line. And so the simulation app does that for me, and it's about 0.32. That's the simulated p-value, and that's above 0.05. So then I need to make my conclusion. We don't say, well, the null hypothesis is not true. That's incorrect. We have to make a decision of whether we're going to reject the null hypothesis. And so I will conclude there's no statistical significant difference in the effectiveness of red and blue medication. I decided to reject the null because the strength of the evidence is weak. All right, so now this video is going to conclude, and I'd like you to spend some time reviewing the two little check boxes. Think about what you didn't understand before here. I think there might be some others that I didn't put in that checklist, and then let me know if it's cleared up. If it's not, it's important that you tell me so that I can readjust when I come back and fold it into my class time.